Alright, so quick videos to show you how you can come up with these on the fly in case you forget, but it's something that you do not want to do. You just want to memorize them, but I want you to see with this natural log, how do we come up with the integral of tangent? Okay, a misconception right now is that we already know what the integral of tangent is, and we really don't. We know the derivative of tangent is secant squared, okay? Which means that we know the integral of secant squared is equal to tangent, okay? But we don't know yet what the integral of tangent is. Okay, so now let's go ahead and rewrite this and use what we've recently learned to be able to come up with it. Okay, so sine over cosine is tangent. If you see what u should be, u is cosine of x, what would du be? Yes, negative sine of x dx. And you picked up those pieces just now, except for that negative that you will account for, of course, in your rewrite. Okay, so it's going to be 1 over u du, which the integral is the natural log of the absolute value of cosine of x, and then it's plus c. But make sure you don't forget about this negative that is right here. Okay, and I don't know, there's different things that you guys use to help yourselves memorize certain things, you know what I mean, and some weird ways that you can. Someone said this and it stuck, like some people just got it. The integral, and it was a student, of tangent was no tacos. So if that helps you to memorize that the integral of tangent is negative cosine, then by all means use it, okay? Another one that I want you to be aware of is laws of logs, okay? Laws of logs say that this one that I said in previous classes or even ed puzzles, the one that most people forget, the natural log of a raised to the power of b is equivalent to b times the natural log of a, okay? So this negative that you see here, I actually can bring it inside of the argument as a negative power, but be careful that you understand what that means. When you do that, it's not applied to the x, it's applied to the entire thing. What is that equal to? What is cosine to the negative 1 like that equal to? Secant. Because it'd be 1 over cosine, which is the same as secant. So you can have a positive absolute value of secant x. This is another form of an answer for the integral of tangent. Either one is acceptable, okay? Alright. Alright, so let's do the next one. This next one is cotangent. We're going to start it the same way. We're going to have cosine of x over the sine of x. Oops. And it's going to be dx. So anyone, what's my u? Sine of x, yeah? U is sine of x du, cosine of x dx. Nice. So that my integral is going to be what? 1 over u du, right? No negative to worry about. And let's go ahead and, we know this, the natural log of the absolute value of u, and you would get cotangent was that one. And I don't know, I can't really remember if they came up with an acronym or something cool to remember on that. I think they did. Cotangent, they saw something like cosine or something like that. You know what I'm saying? So whatever helps you get it, go for it. Any questions so far? Alright, so let's do the next part. These are a little bit weird. These are a little bit more involved because if I rewrote this right now, it's 1 over cosine, but there's no derivative up top. Like if I were to say, alright, I see that I could probably use u is equal to cosine of x. When I take this and get negative sine of x dx, this appeared out of nowhere, which was not in the original problem. So we can't necessarily do that. Okay, so this one's a little bit different. You with me? This is what I'll say. secant of x over 1 is my original piece. Okay? And if I manipulate this by something that you would never think to do this, chances are you would never think to actually do something like this. Secant x plus tangent x. You see what I'm doing? Over secant x plus tangent of x. Is this allowable, yes or no?
Yes.
Why? Because what did I just do? Multiply by a form of 1. And you probably would have never think up to do that. But if I do, look at the distribution that just occurs. Okay? So what I really have equivalent is secant squared x plus secant x tangent x. And on the bottom, order doesn't matter, does it, with addition? So you could write secant plus tangent, or you could write, you see what I'm doing? Tangent of x plus secant of x. What do you think my u is now? Yeah, my denominator. So u is tangent x plus secant x du. What's du, guys? Secant squared plus secant tangent dx. Nice. Which, what we just did after we created that form of 1 and did my derivative, is that we picked up our entire newly created numerator. You see that? So now my rewrite is 1 over u du, which the natural log of the absolute value of u, and you can write it as secant plus tangent or tangent plus secant, it doesn't matter. I'll probably write it like this just to be in alphabetical order, and then plus c. Yeah?
So I got a question. So on the tests, if we have a problem just like that, and you want us to memorize it, do we still have to show?
No, if you get a question like this, I want you, and then it's going to be bounded, like you're going to have different bounds. I want you to go straight from this thing to writing this, which you would have, and that was good timing on that, thank you, Will. It would be the natural log of the absolute value of secant x plus tangent x, and it would be bounded from a to b. You plug them in and you get your answers. We good? And that's a lot of work by hand. We have to remember the unit circle. Okay? Alright, so this next one, we're going to multiply by another form of 1. You with me? So think about what we just did. You saw the derivative of this guy right here. You saw the derivative of this. And what form of 1 do you think we will end up multiplying this inside by? Cosecant. Okay? And plus or minus? Let's try minus, because cos are usually minus or negative, or they are when we're checking derivatives. So that's a good way to kind of memory store it.
So could we just put plus and turn minus on the outside? Would that affect anything?
It would. I would rather you do it on the inside. That's a really good question. Where do I put this minus? It's going to be easier to see if we put cosecant minus cotangent, or it's the other way around, cotangent minus cosecant. We're going to find out here in just a bit, okay? So let's do this. So cosecant x minus cotangent x. Now let's think about this, okay? We know the bottom is going to be u. What's the derivative of cosecant? Negative cosecant cotangent, right? And look at this. Negative cosecant cotangent is right there. You with me? What's the derivative of cotangent by itself? Negative cosecant squared, right? But then we have to multiply by that negative there. You see what's going on? Then it's going to give us this positive cosecant squared on top after it would distribute. If you need to rewind the video or whatever and pause it, you'll understand. Because the other way, you're going to have to worry about that negative, and it's not as convenient. You know what I'm saying? So, to me, yeah, I think our approach as far as what we put in for you is pretty good. It'll work. So we have the integral of cosecant squared x minus cosecant x cotangent x all over cosecant x minus cotangent x. Oh yes, dx. Nice. So u is our entire thing, our entire denominator. Du is negative cosecant x cotangent x. And then now we got to worry about this, which is minus a negative cosecant squared x. Oops, that's not cosecant. Okay, and dx. And this is what you see. You don't see it necessarily in the same order, but there's my positive, okay, and there's the dx, and then all of this is right here. So our rewrite does become 1 over u du without having to worry about weird negatives, okay? So that my integral is simply going to be the natural log of the absolute value of what? Cosecant minus cotangent. Again, these should be memorized, and they're not that bad, guys. Word to the wise, when you go to Calc 2, there's about 40 that you memorize that are something like that. There's a lot of memorization. That's why when people struggle with Calc 2, it's because of memorization. Okay? So let's go to this table real quick. Cosecant, we said, was cosecant minus cotangent. That's not what they have. They have cosecant plus cotangent.
They have a negative.
But they have the negative, and that's taking in that effect, okay? That's what's going on there. So if we did the negative, the way he was suggesting, it's still going to be equivalent. Do you understand? Okay. Cotangent, we said it was the natural log of sine, and they have the same. Tangent, we said, was either the negative tacos or the natural log of secant. You see the negative tacos, but we know it's the same. Okay? And then the last one, secant, we solved it out as... Oh, I erased it. Do you remember what it was?
You have it up there, right by the secant x plus.
Oh, right here. Thank you. Secant plus tangent, and that's what you see. Are we good? So the variations, or guys, if you want to just be safe and you're good with memorizing stuff, just memorize this table exactly how you see it.
Now, because the absolute value, can we actually have the negative natural log, and then inside also have cosecant u minus cotangent u?
You can. The thing that's happening there is it deals with it, but it's dealing with powers, and these are adding. So because it's not, that's a really good question. Well, it's because it's not multiplied, that's why it's not a big deal. If it was multiplied, then something else is occurring. But it's that whole thing is raised to the power of 1, so it's like 1 over the stuff. That negative is still equivalent. We good? Alright. So let's do a couple of examples. The tangent of 3x. What do I do? So
Skip, right?
u is, yeah, well, I'm saying, how do you do this? What do you do to start? Okay, so now we're going to use what's memorized. So we're going to say u is 3x, so that du is 3dx. You see what we're doing now? Because now the rewrite is going to be 1/3 tangent of u du. And now that we have it in this form, we want to use no tacos. And this is what you want to do on the test. Okay? So this integral is going to be constant multiple rule, the 1/3, of course. Right? And then you have negative natural log of cosine. And be careful because what goes there? U. So we'll say 3x. You with me? And then yeah, at the end you don't need this because of the fact 1/3 c for all intents and purposes right now is still 1/3 c, or sorry, it's still c. So we'll say negative 1/3 natural log of cosine of 3x plus c.
Would it? Oh, I'm sorry.
Are we good? Okay. Alright, let's do the next one. What is u on the next one? X cubed. So du is 3x squared dx. So it's going to be 1/3 secant of u du. You with me? And then secant, the way I memorize it, guys, what's the derivative of secant? Secant tangent. Look at that. Just make sure you're at it. You with me? What's the derivative of cosecant? Negative cosecant cotangent. You see what's going on? I think it's kind of, you can see it as far as from the derivatives that you have memorized. Okay? So we're going to say this is equal to 1/3 natural log of the absolute value of secant u, right? And then plus tangent u plus c. Guys, should I always be concerned about replacing this u back in, yes or no?
Yeah.
If and only if it's a what integral? Indefinite. If it's a definite and actually has limits of integration, you want to change those to u bounds, right? And then just leave it with u at the end because it's going to be a lot easier algebraically.
Could you take the 1/3 or the third power for the x, and then because with the natural log, with the rules, like take it out, so then
You can put it in and take it out, yeah.
So then you get rid of the 1/3.
Yeah, well, if you took that 1/3 inside, again, it's an additive. It's not multiplied right here. So it's a binomial, so there's more going on. It's like all of that raised to the 1/3 power, then the absolute values are here. You see what's going on? Okay. If you are worried about that, I would not bring it in. Don't worry about bringing it in. Okay? And then this is just more practice, guys. You would do u sub as far as u is x over 3. Anyone, what's du? 1/3. Well, 1/3 dx. Think about it like this, guys. Constant multiple rule, that 1/3. What's left? X. What's the derivative? No. What's the derivative differential-wise? dx. Then multiply that 1/3 back in. So it would be 5 minus the cotangent of u du. Right? Okay?
Shouldn't there be 3 in the front?
Yes, there should be. So we should do this actually. 5 dx. See what I'm doing? Minus 1/3. I didn't have to do it for the 5, did I? So I split it up. I have subtraction, therefore I have two problems. The 5 and this guy. Oh, nice catch. Nice catch, Jake. It's a 3 because we have to 1/3, you know what I mean? Move it over to the other side, so it's nice catch. It's going to be 3 times that. So what's the integral of cotangent? Like, let's try to memorize it without looking back. What's the integral of cotangent? Oof, there's a lot of stuff going on right now. Let's go back real quick. It's going to be natural log of sine of u. It's not these guys. It's that short one right there, the natural log of sine. Okay, and this right here, I'm not even kidding. It was good time too. This one's the one that's mostly forgotten. Because of the way no tacos and these are the derivatives, that's the one that most people forget. So natural log of sine of u. So the natural log of sine of the absolute value of u. And what are we going to plug in for u? X over 3. Right? And we still have this minus 3, right? And at the end we have plus c. And then this one, what's this one just become? 5x. Done. Okay? And last but not least, little bit of review of this thing. Remember that? The average value of a function. So if we're trying to take the average value of that, what we need to do 1 over b minus a of that function from a to b. And we'll be done with it. Okay? So find the average value. Here we go. 1 over 2 minus 0, because this is a and b. Okay, from 0 to 2. We good? Okay. We're going to have to rewrite this, right? We're going to have to rewrite this because what of that says we're going to have to rewrite it? What piece of that says that there's going to be some rewriting going on?
Like the coefficient is not known.
Nice. The fact that the coefficient is not positive 1. So it's got to be u is equal to secant, or no, my bad. U is equal to what?
Pi x over 6.
Good. Pi x over 6. Therefore, du is equal to?
Pi over 16.
Good. Pi over 6. That's constant multiple rule. Then dx, right? So that this is going to become 6 over pi with the flip, right? So, hold on just a bit. Because right now, yeah, that's right. So it's going to be 6 over pi. So it's going to be 3 pi because that reduces to 3. And it's going to be secant of what?
U.
U du. Guys, what is wrong with my stuff right now?
Your
Go ahead and say
limit,
it. Yeah, you see it, What's wrong right now?
your limits aren't set to U.
Yep, my limits need to change to u limits. So they used to be 0 to 2, right? Now, let's plug in that 0. What do we get? 0. Let's plug in the 2. What do we get?
Pi over 3.
Pi over 3. Nicely done. Now.
Wouldn't that also change to b minus a?
No, well that still, no, that doesn't change.
Oh.
We're just changing the limits. That 1 over 2 original is going to multiply with my 6 over pi. Because remember, you have to get this over to the other side.
Yeah.
And that reduces it to, oh, it's not 3 pi. It's 3 over pi. Okay? Do you see it?
Yes, you just keep it the same.
So 3 over pi is what that should have been. Good? Do y'all agree? Do y'all agree? Alright. She just wanted to be on camera laughing. Anyway, so what is the camera? There's not even a camera. Anyway, what's the integral of secant? Anyone? Yep, natural log of that secant tangent stuff, right? So it'll be secant of u plus tangent of u. No plus c on this one though because it's definite. Yep. From 0 to pi over 3, and then at the very end we will constant multiple rule the 3 over pi. Alright, so that's a lot, and this is going to be done without a calculator, so we've got to bring that unit circle back. So, pi over 3. I'm thinking of pi over 3. Let me make some room so that you can see it. Alright, so pi over 3 is here. So it's 3, 2, 1, and then 3, 2, 1, all over 2, square root the top. And secant is the flip of cosine. So it's just going to be what? 2. So this will be 2, so I'll put it over here. Natural log of 2 plus, what's the tangent, which is the y over x? What's the y? Let me write it out. The y divided by the x. Remember how I told you should probably do it to help you kind of see it a little bit better? Keep change flip will now reduce to? Square root 3. See that? Why do I have parentheses right now? Because now they're constants. There's no more, you know what I'm saying? There's no more u's left. So this is f of b, guys. Minus, now we got to plug in 0. And I know I'm kind of showing a lot of work, but I just want to make sure people who watch the video can see all the pieces. So it's going to be, what's the secant, which means the flip of the x, at 0? Yeah, it's 1. Okay, so that'll be natural log of 1. And then, what's the tangent at 0? Which is the y over x, otherwise the slope. What's the slope of that line? 0. So plus 0. Okay? What does this become, guys, right here? Some of you already see it.
Zero.
0, because the natural log of 1 is 0 from that graph that we remembered as far as its default parent function. So my final answer is just going to be 3 over pi times the natural log of this, which you can leave it just like that. Because I don't expect you to know that value without the calculator. That's all the time.